Welcome to the world of data structures. Our today's topic is hashing and hash functions. Hi, this is your instructor Janice Shah. So let's begin with today's outlines. Students, today we are going to first see about why the hashing is important, what do we mean by hashing, how the hash table works, then hash functions, and then we'll see the different types of hash functions. Okay, so first let's understand why the hashing is important. See, whenever you try to search on the internet like the best score of Virendra Sehwag or the best century of Sachin Tendulkar, then at that time your computer or the Google algorithm works a lot and get a result for you. So this searching mechanism is not able to give you result instantly. Okay, that means only in one comparison they are not giving you the result. Okay, there are lots of data are there on the internet or in the data structures on the database of the servers, and from that the algorithm should need to find out the exact data that you want. Okay, so it is very much clumsy or time consuming process for all of us. So what happens exactly in the traditional data structure? The traditional data structure, like in array and linked list, if you want to search in array, then you might get like a binary search or a sequential search. At the time the binary search mechanism may be the time complexity is O of log n. That means for 10 number of records you need to search at least 3 times. So at that time we need an algorithm which can improve our performance, or which can improve our search performance or give a search performance in a constant time. Constant time, that means we can say like O of 1. Okay, so ideally in one comparison you will get the result. It is not possible, but we try to just make nearer to O of 1, and the method which gives you performance very close to O of 1, that search algorithm is called as hashing. So what do we mean by hashing? Is hashing a data structure? No, hashing is a algorithm, hashing is a technique, hashing is a method that gives you a search result nearest to O of 1 in a constant time. Okay, so hashing is a technique or an algorithm. Now next we have the hash functions. See, hashing is a method to find out the data, but from where we are going to find the data? Okay, so here our data is stored in a fixed size array, or we can say the hash table. Okay, so the hash table is what? See, hash table is a data structure. Okay, so hash table is a data structure for hashing, we can say, where we store our data or from where we are retrieving our data. So hash table is nothing but a fixed size array, but the storing and the accessing process of the data is little bit different than array. It goes according to the hashing methodology. So next we have the hash functions. See, why we are using hash function, or what do we mean by hash function? See students, to insert a data in the hash tables or to retrieve the data, first what we store over there, we store keys over there, key values. Okay, so for the key we need to search out that at which index we need to store our key data. Okay, so first you need to apply the hash function on the key values and then get the hash value, or you can say the index value of the hash table. Okay, so the hash function is used to find out the hash value or the index value where we need to store our key data. Fine. So hash function is a function that can be used to map a data set of an arbitrary size of data set to a fixed size which falls into the hash table. Fine. Here the values written by the hash function are known as hash value, hash codes, hash sums, or simply hashes, or the index of the hash table. Okay, so what do you actually do over there, students? If you have data like 100, okay, so on 100 data you need to apply your hash function. Okay, so after applying the hash function, if you get answer like 5, that means you need to store 100 at 5th index. If you get answer like 7, that means you need to store 100 value at 7th index. So what we get after applying the hash function on the data? So after applying the hash function on the data, we get hash value or the index value of the hash table. Fine. Now let's see the example of the hash table. So here is our hash table over there. Okay, that shows the keys data. Okay, the key are stored over there. Okay, so hash table starts is a one like a fixed size array. So array index starts from the 0 to n minus 1. Suppose if I want to store k1 data, so I need to apply hash function over k1. So it gives h of k1, that shows the hash value or the index of the table. Here if you can see the h of k1 is there in the table. So h of k1 that shows the index value of the table where I want to store my k1 value. Okay, let me take this example. So here it is. See, if the hash function is h of key is equal to value modular n, or you can say key modular n. This is our hash function. Just imagine this is very basic hash function where h of key is equal to value modular n. So let's take a data like 10, 35 and 48. Now hash table size is 10. See, n is equal to hash table size. Data which we want to insert is 10, 35 and 48. So what we need to do is we just need to apply hash function on values, okay, or the key values. After that we get the actual index value. Suppose our first value that we want to insert, suppose students I want to insert 10 in hash table, then how can I insert? See, h of 10, I need to find h of 10. So what is the function or what is the formula for h of 10? If you can see over there, the h of 10 is equal to value modular n. So here it is. For h of 10, we need to write 10 modular 10. 10 modular 10, that becomes 0. So here 10 will be inserted at the 0th position. So what is 0 we get? That is our hash value. Okay, h of 10 is hash function. 10 is a, okay, so here 10 is a key as well as 10 is the size of the hash table. Now suppose if I want to insert h of 35, then 35 modular 10 is equal to 5. So here 35 is a key, 10 is a hash table size, 35 modular 10 is equal to 5. So here 5 becomes our hash value or the table index. Next we have 48. So h of 48, so 48 modular 10, that becomes 8. So we need to insert 48 at 8th index of the hash table. Fine. So such like this you can insert your data after applying the hash function on the key values. So this is how our hash table works. Now let's see the types of the hash functions. See, here are the basic types of the hash functions. The first method that you need to learn is division remainder method. Then we'll see the multiplication method, then folded key method, and the last one is mid square method. Okay, so let's start with the first hash function, that is known as division remainder method. So the method which we have just recently seen, that is known as division remainder method. It is also known as simplest method or most common method that we are going to use for the find out the hash values. Okay, suppose the given values is key k. Okay, so key is a k, and then the number of slot in the hash table or the size of the hash table is n. Then the hash function goes like this: h of k is equal to k mod n. This is our first hash function, which is known as division remainder method, where you need to apply k mod n. K is your key that you want to insert, n is a hash table size. Whatever the value you get, whatever the remainder you get from that becomes your hash value or the table index value. Okay, so here the index of the hash table is k modular n, the remainder value. Fine. So here the technique is very much easy and well known, that is known as hash function division remainder method. So let's take the example. Suppose if we have n is equal to 101, that means table size is 101. Now the key value is 11 2 3 4 5 6. 11 2 3 4 5 6. So what I need to do is, if I want to insert this key into my hash table, okay, so how to do that? First I need to apply hash function over there. So here my hash function h of k is equal to h of 11 2 3 4 5 6 is equal to, see, hash function 11 2 3 4 5 6 modular 101, that becomes 33. Okay, so when I am just finding out the modular of this, it returns 33. So where I need to insert the data, I need to insert the data at 33 index. So students, what is 33? 33 is a hash value or the hash index. Now next we have, so the key is stored at the 33 index hash table. Okay, so next we have the next multiplication method, second hash function, that is known as multiplication method. So here it is, the first key k is multiplied by constant c. Here key k is multiplied with constant c. Then here the c value is from 0 to 1. Then you need to find out the fractional part of the product of kc. How to extract the fractional part, that we will see. Then you just need to find out the floor value, or the floor value of that is multiplied by n, and then you will get your answer. So how to do that? Let's see. First check the formula for multiplication method. So formula for multiplication method is floor of n into kc mod 1, n into kc mod 1. So what you need to do is, here c is a constant and value is already given, k that a value that we want to insert, mod 1. Okay, so here the mod 1 that shows to extract the fractional part, that means decimal part. Okay, let's see how. See, if I take in the example like if my k is equal to 132437 and n is equal to 101, then first I need to count k into c. So here the value of c is given 0.610339 dash dash dash, whatever it is a constant value. Okay, so here h of k is equal to, that means h of 132437 is equal to floor of 101 and n into kc mod 1, k, that means 132437 into c mod 1. So whatever the answer you get after multiplication of k and c, so here it is, the answer is 81850 into, check the inner part, 81850 into 5673650. So here the red highlighted part is known as fractional part. When you apply mod 1, it returns the fractional part, that means 0.567350658. You will get that answer. So here it is, 101 into 0.5673680680698. So now just need to multiply with both of them, 101 and that, it returns 57.304. So the floor value of that is 57. Okay, so that becomes your index value. So if you want to insert 132437, then you can insert at 57th index. Now let's see the next folded key method. So the third hash function is folded key method. It is divided into two different steps. Step number 1, that is, in this key k is divided into several groups from the leftmost digit, where each group is consist n number of digits. So what you need to do is, you just need to divide your whole key into several number of groups. After that you just need to add all of them. Okay, so let's understand, or how to divide them in a group, let's understand it. So here it is, the first example here we have n is equal to 100. Students, if n is equal to 100, now tell me, if n is equal to 100, then array index should be ranged from 0 to 99. 0 to 99. So the maximum digit you have, that is 2. 99, that means 2 digits. Okay, so for 0 to 99, here we have maximum digit 2. So you need to divide your key into two groups. So here we have our key like 132437. So what I am going to do is, I am just going to divide the key from left to right into two parts. So first I have 13, then 24, then 37. After dividing this key into two digit groups, you just need to add all of them. So the answer is 74. So 74 becomes your index value. Now the question is, suppose sir, if somehow my index values are greater than 100, then what to do? Because here our array is 0 to 99. So if you have like digits like 247, 348 in index value, then what to do? At that time you just need to ignore the first carry. Suppose my another example is, see, 6578459. So for n is equal to 100, I need to divide into two equal parts. So here it is my answer. Okay, when I am dividing them, and calculate it, it returns 197. Okay, so 197 is maximum value. Okay, because that is the array maximum index is 99, so you cannot insert your data at 197. So what you need to do is you just need to ignore the first carry, that is ignore 1. What you get? 97. So here you need to insert your value at 97th index. Fine. Now let's take the last hash function of today's lecture. Here it is, the mid square method. Students, in mid square method what you need to do is first you need to square of your key. Need to do square of your key, then ignore or remove some digits from the left side and the right side of k square. Okay, please understand here k2 is not a k2, it's a k square. Okay, so square of a key is equal to k square, then some of the digits from the left and right end of the k square are need to remove. Suppose, and whatever the remove you get after removing it, that becomes your hash value. Suppose our key is 132437. If I want to square it, it returns 175,955,8969. Okay, so here my n is equal to 1000. So I can easily say that my array index should range from 0 to 999. My n is equal to 1000. So I can say that my array index should range from 0 to 999. So what I need to do is I just need to remove some digits from the left side and the right side of this square answer, and then I get 955. So here my answer is 955. Okay, so how many digits we should remove? See, mostly equally digits. If you remove from left side like 3 or 4 digits and right side only 1 digit, then it's not proper. You need to remove equal digits from the both side or mostly near to equal. Like left side I have just removed 3 and right side I removed 4, then it's fine because only one difference is there. But always make sure your answer must be in the range of array indexes, because here my range is 0 to 999 and my answer is 9555, which is already in the range of that. Okay, that's why I can select 955. Okay, so that's it for today's lecture, students. Thank you so much.